Okay, I just wanted to start over. What comes to mind the first time that you see this, especially forces? Is it moving? That's why we said that's a trick question. Can be. Can be. So we call it kind of a paradox. It can be both. Okay? So when we think of that, there are certain things that exist. Some microscopic structures exist as particles. They also exist as waves. That's what we call a paradox. They're going to be one or the other. So when we talk about forces, they can be something that is moving. It can also be not moving, because when you look at that acceleration, what is it that could possibly be something that is not moving? Your problem that yesterday with the helicopters, okay? When that payload is on that top helicopter, a lot of you had questions on that and said, well, it's just dangling there, okay? The helicopter is moving, but the payload itself, is it moving? But does it have force acting on it? Yes. But we just said, wait a minute, forces have to have movement within them. Yes, that's true too. So how can something not be moving and be a force? Because what is acting upon this that gives it value once you let it go? Remember, this is the vertical component. Gravity is acting upon it. Does gravity have an acceleration? Yes. So even if it is not moving, it still has a force acting upon it, because that is a force, because it also has a mass. That's also known as weight. Weights are also forces, because when you look at this, you're taller than I am. Even though this young man's taller than I am, who has a greater force / weight to them?
Ryder. No, Mr. McKenna.
I don't know.
Ryder.
How much
Definitely Row. What?
you know?
I'm just asking.
Do you weigh less
Okay.
than like 160?
Like, oh.
I wish. At one time I did. So let's look at this again. Forces are also weights. Okay? We have gravity acting upon us both at the same time. But who's got a larger mass? See? My belly is not the same size as his. So, okay. All right. Hold that thought now. Some of this is based upon prior knowledge that you learned in earth science. So with that, in this entire solar system, great, we're talking about earth science. Isn't that awful? Okay. We like physical science better, don't we? Well, you just said that you didn't want to talk about earth science. So that must mean you want to talk about physical science.
We don't want to talk about either.
Okay. Okay. All right. Save that for tomorrow. But regardless, in our solar system / the Milky Way, where would you be the heaviest you could possibly be? It's not on Earth.
Mars. The moon. Jupiter. Neptune. Saturn. Jupiter. Which one?
On Jupiter?
Oh, I said Jupiter.
What did you say at first?
Uranus.
You were the first one.
Jupiter?
Why is it Jupiter? It has the largest mass. Okay. We got a job to do here, people. Just let me do it, all right? But that doesn't answer the question. Why is it Jupiter? Why did you say that?
It
Has the biggest mass. But even though that's That's where people think. Why is that incorrect?
It has a high gravity.
It's actually the sun, but you can't survive there. But that's why it's kind of a trick question.
It's
Okay?
got a lot of gravity. That's
All right.
why.
So gravity is always acting on any object regardless of its mass. So, as astronauts land on the moon, let's say they want to do a long jump on there. How many of you do the long jump in track? Anybody? So if you do the long jump in track here on Earth, a good jump for you might be 14 feet, 15, I don't know. 18 feet? Okay, so a good jump for you would be 18 feet. Should you do that on the moon, how far do you think you might jump? 40 feet maybe? Because the moon has less gravity on it. A person weighs 1/6 as much on the moon. Okay, so moving forward. So what we see happening, the amount of force exerted on an object will be reflected on its velocity and acceleration. Okay? Because you also have to take into account air resistance as well. Okay? That's what we mean here. If you know anything about baseball, which unfortunately, well, Cleveland won last night, so Minnesota didn't clinch the Central Division yet, but their magic number is down to like 2, I believe. But does anyone follow baseball? Even softball? We'll just say softball, because since we had our first initial season of softball last spring. No softball players? Okay. So now we're really good if we're a pitcher or a catcher. Anybody? Which one? Okay. So as a catcher, do you call your own pitches or whatever the pitcher's going to throw at you? Okay? So with these two, okay, do softball players throw changeups, fastballs, and curveballs? So it's possible. Okay. So we know that it's possible, but do you know why that happens? Because what? Okay. Well, maybe so. But when you look at a baseball or a softball, what type of shape is that? It's a sphere. Okay? Because a circle is just 2 dimensions. A sphere is actually 3 dimensions. So on this 3-dimensional object, is that is that sphere smooth? Why are you right? Because you're right. Doesn't everyone like to hear that they're right? So you are right. Why are you right? Do you suppose there's actually 3 reasons for those laces on there. 1, so you can actually sew the cover on there. 2, if you are an outfielder or an infielder or even that catcher, once you catch that ball, would that be easy to throw a sphere with no seams on there? You're shaking your head no, you're right again. Why are you right? It gives you a good grip on there. And then finally, with you being a catcher, what do you suppose we said these seams that you see on a baseball or softball will have an effect on how that travels? Okay? One of the things, what about with volleyball? For those of you who are playing, do you ever see the volleyball coming at you and there is absolutely no spin on that at all? So when that happens, it travels straight. No, it's like moving through the air like this. That's kind of like a knuckleball effect. There's actually pitchers that could throw knuckleballs, and when they do that, that ball is not spinning at all. You don't know if it's going up, you don't know if it's going down, you don't know if it's going left or right. But when you are expecting a curveball, what happens if they throw you a slider? Are you caught off guard? Probably. You're probably not very happy because it's coming in. That's why we say it's coming in hot. Have you ever heard that before? Okay, so those ridges, seams, whatever, will affect how that ball will travel. Okay, so when we talk about velocity and acceleration, okay, what has a greater velocity, a fastball or a curveball? That's why it's called a fastball. Because as that is traveling, what's the best I can do for a sphere? I don't have a baseball or a softball, but you're pointing at one. Where's there? Oh, sure. Okay. It even has seams on it. Okay. So what we see happening, whether it's with softball or a curveball, okay, if a grip is like this across its seams and it leaves the finger like this, it's rotating through the air like this. And it has a nice straight path to it. Okay? But, and I don't know, now with a softball, I would think the grip would be similar. It's just that how does it come out of, does it come out of the hand like this, or does it come out of the hand like that? It's curveball. Does it look like this? No. And then you grip it like this, and then does it rotate coming off the hand, or does it come off? It can't come off straight. That would be a fastball then. Does it come off just this one finger then? And should it spin like this on its axis? It doesn't go straight, because then it's not going to move. But should it come off like this and it tumbles, all that air resistance is going over these seams, and it's going to cause it to typically, when you hear what's called a 12-6 curveball, whether it's baseball or softball, what type of movement do you think that means by 12-6? Just think of a clock. Where's 12 at?
At the top.
Where's 6 at? So then typically that starts out high and comes out down low. Okay? So that's why they call it a 12-6 curveball. Then what happens with, is there a slider, or is it just fastball and curveball? Are those the only two that you call?
No, fast, change, drop, curve.
Okay. So then I would think, is this a fastball like this then? So then this must be a changeup like this. No?
You grab the top of the ball and release.
Okay, you grab like that.
So you do it like your 2 fingers, and then when you release though, like you don't release like this, you release like this.
Huh. So that's a changeup? So it goes like, okay. I would think so too. So as it's coming like this, gets released with that. Okay. So there's something, I think I've got the wrong video. So I want to catch that quick So just hold that thought. Okay, so hold up just a moment. All right. Hold up just a moment. Okay. While that's loading up, as you can see, next week we'll start problem solving, and then your vocabulary will formally be assigned on Tuesday, and then a week from today that will be due. All right. Now, with one of the things, it says the arch. That will be your first hands-on activity, and I just keep this as a template. So one of the things that you will do, a template just means something that you copy. Okay? So when this was made, you will design your own arch. Okay? So does anyone, this is just a wild guess on your part, who were probably the first engineers that designed the arch? You got to think a long time ago. No. It's over in Europe. Not the Egyptians, because that would be on Africa. We're talking about Europe. The Romans. It's depicted off of the Roman arch. So it is your opportunity to play engineer, architect, and demolitionist, which means you're going to break it. You design it, you test it, and you break it. Okay, so that's what we have coming up next week. This is all I have for that we're recording. So the rest of the time we will watch this about athletics. Catch up to you next time.